Welcome back in lecture series on topic electrochemistry. In last video, we have studied electrolysis of molten sodium chloride. And you know that during electrolysis of molten sodium chloride, sodium metal is deposited at cathode and chlorine gas is liberated at anode. Now today in this lecture, we will learn electrolysis of aqueous sodium chloride. In case of electrolysis of aqueous sodium chloride, the construction of electrolytic cell is same as that of the molten sodium chloride. But the reactions which takes place at cathode and anode are different one. So let us see the electrolysis of aqueous sodium chloride. So electrolysis of aqueous sodium chloride is carried out in electrolytic cell like this. And this cell contains moderately concentrated aqueous sodium chloride solution. Here moderately concentrated word is used as the product depends upon the concentration of sodium chloride. And in this electrolytic cell, two graphite rods or platinum rods, which are inert one, they are dipped in this electrolyte solution. And these two inert rods made up of graphite or platinum, these are connected to the direct source of direct current, that is battery. And the electrode which is connected to positive terminal, that is called as a anode, and electrode which is connected to negative terminal, that is called as a cathode. So this is about what? The construction of electrolytic cell in case of aqueous sodium chloride. Construction is same, but the electrolyte is different. So see here the working of this cell. In this cell, aqueous sodium chloride is also there and water is also there. So both get dissociated and gives here, you know that sodium chloride when dissolved in water, you get a sodium chloride solution, aqueous sodium chloride solution, and aqueous sodium chloride dissociate and gives you sodium ions and chloride ions. So in electrolyte solution, sodium ions and chloride ions are there. And water is also there, and that water also dissociate partially and gives you hydrogen ion and OH ion. So from water in electrolyte, hydrogen ions are also there and OH ions are also there. Now when electricity is passed through this solution, then these positively charged ions, that is sodium ion and hydrogen ion, they migrate towards negatively charged electrode, and the chloride ions and OH ions, they migrate towards the positively charged electrode. This one is the positively charged electrode. So chloride ion and OH ions migrate towards this, and hydrogen ions and sodium ions migrate towards the negatively charged electrode. Now what happens here? How the reaction takes place? See here. At cathode, that is at negative electrode, reduction takes place. You know that reduction means gain of electron. So sodium ions migrate towards negatively charged electrode, and where they accept electron, gain electron and get discharged and get deposited and forms sodium metal. And water is there, and water contain hydrogen ions. These hydrogen ions from water accept electron and form hydrogen gas and 2 OH ions. So 2 reduction reaction, in both reaction electron is accepted. So 2 reduction reactions takes place at cathode, and there is a competition between these 2 reactions, that is reduction of water to hydrogen and second one, that is reduction of sodium ion to sodium metal. But those reactions which have the high standard reduction potential, that will takes place preferentially. And according to that, standard electrode potential means what? Standard reduction potential or standard oxidation potential means the potential developed due to reduction reaction or oxidation reaction under standard condition, then that is called as the standard oxidation potential or standard reduction potential, that we will see in detail later on. But now here consider this, and this is represented as a E0. Standard potential is represented as E0. Now as it is a reduction reaction, it is a standard reduction potential, and it is equal to minus 0.83 volt. And here when sodium ion accept electron and forms sodium solid, then of this reaction standard reduction potential is minus 2.71 volt. Now what happens here? There is a competition between these two reactions, and the reaction whose standard reduction potential is more, that will takes place at the cathode. So here it is minus 0.83 and it is what? Minus 2.7. So which reaction will takes place at cathode? Reduction of water to hydrogen. It is a higher. So what happens here? The hydrogen gas is liberated at cathode. So why? Because standard electrode potential of water is water to hydrogen gas is how much? Minus 0.83 volt, and it is greater than that of the sodium ion, which is minus 2.71 volt. And hence at cathode hydrogen gas is liberated. Now at anode what happens? See here. At anode oxidation takes place. And oxidation means loss of electron. So here at the anode, two chloride ions gives chlorine gas and 2 electron. It loses its charge and gives chlorine gas. And the standard oxidation, it is an oxidation process. So the potential developed is called as a oxidation potential, and under standard condition it is called as a standard oxidation potential. So standard oxidation potential of this reaction is minus 1.36 volt, and the water is also there. So this water gives you hydrogen ions and oxygen gas is liberated, and 4 electrons are lost, and oxidation potential of this water is minus 0.4 volt. Now there is again competition between the oxidation of chloride ion to chlorine gas and oxidation of water to oxygen at anode. And if you observe the values of standard oxidation potential, then standard oxidation potential of oxidation of water is more or higher than standard oxidation potential of chloride ion to chlorine gas. And therefore here at anode the oxygen should evolve, but as the water has a greater tendency to undergo oxidation from standard oxidation potential. Standard oxidation potential for the water is minus 0.4 volt, and which is greater than that of the chloride ion, which is minus 1.36 volt. Now what happens here? Actually in experiment at anode, instead of oxygen, chlorine gas is evolved, and this is because of overvoltage. Overvoltage means what? The actual voltage required for electrolysis is more than the calculated or theoretical voltage, standard potential. And this additional voltage is called as a overvoltage. And because of this overvoltage problem, instead of oxygen, chlorine gas is evolved at anode. So the net cell reaction for electrolysis of aqueous sodium chloride is like this. See here, at anode, chloride ions gives you chlorine gas plus 2 electron, and at cathode, water accepts these 2 electron and gives hydrogen gas and 2 OH ion. So overall reaction, cell reaction is 2 Cl ion plus 2 H2O in a liquid state gives you chlorine gas and hydrogen gas, and OH ions are there. So here in the electrolysis of aqueous sodium chloride, hydrogen gas is liberated at cathode and chlorine gas is liberated at anode instead of oxygen, and sodium ions remain unreacted in the solution, as here hydrogen gas is liberated and OH ions are formed at cathode. So in the solution, sodium chloride solution is converted into sodium hydroxide. So in electrolytic cell, sodium hydroxide is there. So like this you can prepare sodium, or you can obtain sodium hydroxide from the electrolysis of sodium chloride solution. Remember here that you cannot get a metal, sodium metal, by the electrolysis of aqueous sodium chloride, but you can get the sodium metal by electrolysis of molten sodium chloride. Remember that is the difference between the electrolysis of molten sodium chloride and aqueous sodium chloride. So product of the electrolysis of molten sodium chloride is a sodium metal, and product of electrolysis of aqueous sodium chloride is NaOH. So here this electrolysis process is also used in refining of metal. That means from impure metal you can get a pure metal. This part you have studied in previous standard, that is in electro refining this electrolysis process is used, and in this process the impure metal act as an anode and pure metal act as a cathode. So this is the electrolysis of copper, electro refining of copper metal, and in this what happens, this impure metal, that is impure copper, is there, and when electricity is passed through this, then this impure rod, that is anode, get dissolved and copper ions get deposited, migrate towards negative electron and get deposited on this pure copper metal, and thus you can get a pure copper metal, and whatever impurities are there, they get settled on as a anode mud in the electrolytic cell. So that is called as a refining of metal. Also it is used in electroplating. If you want to coat a particular object by a particular metal, then suppose here there is a spoon, and if you want to coat this with a silver, then the electroplating process is carried out, and here the silver rod is dipped in silver nitrate solution which acts as electrolyte, and this spoon is connected to negative terminal of the battery, and this Ag rod, silver rod, is connected to positive terminal of the battery, and when electrolysis is carried out, then these Ag ions from this rod get migrates towards what, this cathode, that is negatively charged electrode, and get deposited on this, and thus you can get a coating of silver on the metal. So you can get this coating of desired metal by the same process, that is electrolysis. and it is also, electrolysis process is also used in the production of magnesium metal. Most of the magnesium is obtained from seawater. You know that the sodium, magnesium and sodium, these are present in seawater. Next to sodium, magnesium is there. Most abundant dissolved ions are magnesium ions. And this magnesium is obtained in the form of magnesium chloride from seawater. And then the electrolysis of this magnesium chloride is carried out, so that you can get what? Fused magnesium chloride is carried out, and from that, like so fused sodium chloride, we can get a magnesium metal. So the magnesium metal is obtained by electrolysis of the sea water. Also, this technique is used in electrochemical art. Uh, for example, here aluminium, chromium, tin, these metals can be colored by this electrolysis process, and that electrochemical process is called as anodizing. That process is called as anodizing, and such a type of colored coating you will obtain on the metals such as aluminium, chromium, or the tin metal. So also these keys are colored by the same technique, that is anodizing. And aluminium alloys, these are anodized to increase the corrosion resistance and to allow the dyeing or coloring of the articles which are made from aluminium, chromium, or tin metal. So this technique is also based on electrolysis method. So thank you for watching.